Shell Moerdijk is one of the Netherlands' largest chemical plants, situated in the southwest of Holland, on the banks of the Hollandse Diep. The site extends over 250 hectares and produces 4.5 million tons of product per year. The site now accommodates various production units running complex processes that are used to manufacture base chemicals originating from petroleum. The feedstocks used to produce these products are flammable, and the production processes operate at high pressures and high temperatures. Isolated at one end of the plant are the 80-meter-high flare stacks. The flare stacks are structural steel chimneys used for burning off flammable gas released by pressure relief valves. The released gases are burned as they exit the flare stacks, producing flames and heat of variable intensity, depending on the flow rate of the flammable material. Flare stacks require regular inspection and maintenance, particularly when sited in industrial areas and exposed to aggressive corrosive atmospheric conditions. For this purpose, the stacks normally have to be taken down, thereby shutting down production at the plant at great expense. To avoid the cost of taking down the stacks, Moerdijk has been assessing a new and innovative way of inspecting the flare stacks using unmanned aerial vehicles in the shape of a mini helicopter, which can fly at close proximity to the flare stacks and provide detailed inspection of the structure and flare tips. A British company, Cyberhawk'a Innovations, is one of the leading companies applying this technology and has already provided similar services to the oil and gas industry.
The aim of this innovation is to investigate whether a global service for inspecting our flare tips within Shell would add value to our process safety. And on top of that, we would like to identify other areas of interest for Shell as a broader company. The uniqueness of this project is actually the fact that we use the state-of-the-art technology as provided by our partner Cyberhawk'a. And secondly, the fact that we store the images centrally. We can reuse what we have learned. We can compare in a year from now the images and then see whether the condition of the flare stack has deteriorated. So I think that's the uniqueness of this project. Bring the learnings into Shell. We have used this technology now for 2 weeks in this proof of concept, and we learned a lot. We learned about aviation regulations, we learned about weather conditions, we learned about our conditions at the flare stack, and we learned about our risk management and work permit process. We would like to bring that together into a managerial end report, which we will discuss with our stakeholders in order to get next steps done.